In this video, we're going to take a look at the standard hydrogen electrode. So if you recall, cell potentials or half cell electrode potentials are various different values, and they're laid out generally in a table. So they could have negative values, they could have positive values. But if you notice, the one for hydrogen is at the very center of the table, and it's set at 0 volts. So what this means is that the standard hydrogen electrode is what's used to measure all of the other electrode potentials because they can't be measured in isolation. So they're always measured in reference to a standard electrode. And generally, the standard hydrogen electrode is the one that is chosen. And there's a few reasons why they choose this one in particular. But let's sort of talk about the setup of the electrode itself because it is a bit different. For instance, the electrode itself is typically made out of platinum. And the platinum's used because it's an inert metal. It doesn't readily oxidize. It also doesn't really react with acid as well. So it's good for many, many different reasons. It's really just not very reactive. Okay, and this equation here does have some acid involved, so we do not want our electrode reacting with acid. Now, what's sort of neat about this electrode is that it can act as both an anode as well as a cathode, depending on what else it is set up with. So if it acts as a cathode, then we get the reduction half reaction happening. And so H plus is going to be converted into hydrogen gas. And that's where we might get bubbles of gas forming here. If it's acting, so that's acting reduction at the cathode. If it's acting as an anode, then it's going to undergo the oxidation half reaction, and hydrogen gas is going to then be oxidized and turned into H plus ions. So it's kind of neat because it can work back and forth depending on what else it is set up with. Now, the electrode itself, we do have the platinum here connected through a thin wire to the voltmeter. And this tube here has gas being pumped into it, hydrogen gas, at conditions of SATP. So we've got 100 kPa and 298 Kelvin at 25 degrees Celsius. This is submerged in our electrolyte, and our electrolyte is a acidic solution. Typically, the acid used here is hydrochloric acid, and that's because we would say it's monoprotic. It has one proton in its formula. So this is good. We don't have to worry about any other weird sort of ratios. And then this would be hooked up with the other half cell. And like I said, depending on whether it's what it's connected to, it can act as the anode or it can act as the cathode. So it's a really important one to know where it comes from and the fact that we set its E naught value to 0, and this is just kind of arbitrary. It's a reference point in relation to all of the other electrodes. That's it then for this video. Let's move on to our next task.